This is problem number 5 on chapter 3, assignment number 8 on WebAssign. It happens to be problem 55 in your textbook. And this is about a home run being hit. What I would recommend first is drawing a picture. So here we hit the ball, and I have a parabolic shape, and this is where it hits a wall. Now, in any problem involving a parabola, I would always draw a picture. And where my first contact with the projectile is, I would give that the coordinates 0, 0, and call that time equals 0. And we want to find the time at which it hits the wall and the initial velocity. Now, you have to be careful on this problem. It does tell you that the wall is 130 meters from where it is hit in the x direction. But it does say that it's 21 meters high, this wall. But you have to realize that the ball is hit at 1 meter above the ground. So that would mean this y is 20 meters. So this final point where the ball hits the wall has the coordinates of 130 meters, 20 meters. Okay, now you don't know the initial velocity of the ball in this problem. So this is basically how you do every problem like this. We're just going to call V0 the initial velocity. So define your terms. Now, the problem also tells us that it is hit at an angle of 35 degrees with respect to the horizontal. So I can find my initial component in the x direction. And again, since this is with respect to the horizontal, it's v sub 0 or v0 cosine 35 in the x direction. And the initial velocity in the y direction is v sub 0 sine of 35. Now don't pick up your calculators yet. Now this happens to be a problem that uses parametric equations. What are parametric equations? Well, I can certainly write a parabola y equals x squared. That makes sense to almost everybody. But I'm going to write the distance in terms, both in the x and y direction in terms of time. So you know from kinematics that in the x direction, since there's no acceleration, it's v0x, or initial velocity in the x direction, times time. That's the distance it will travel to the wall in the x direction. And in the y direction, there is acceleration due to the earth pulling down on the projectile or the ball. So that's VOYT plus a term for the acceleration 1/2 a t squared. And a is equal to negative 9.81 meters per second squared. So let's just write that down. Okay, so we do know about one of these points right here, and if we can find a time, that also allows us to find a velocity in the x direction. The velocity in the x direction is Vox, and a velocity in the y direction is the initial velocity in the y direction plus acceleration times time. Okay. Now, the thing is, we don't know the initial velocity. So we are going to start out by using the first equation here. And we're going to substitute in the value of dx, which is 130, where it happens to hit the wall. So we have 130 equals, now what do we have here? V sub 0 cosine 35, and that's all times t, which means we can solve for t. This is a rather simple equation in which to solve for t. It's going to be a literal equation because we do have another variable, v sub 0, in here. So it's 130 divided by v sub 0 cosine 35. All right. Now we're going to use the second equation. And we know in the second equation, d sub y is 20, so we'll substitute that in. And the initial velocity in the y direction is v sub 0 sine 35 times t. And then we have plus 1/2 at squared. Now, 1a is negative 9.81, so 1/2 of a is negative 4.9, roughly, t squared. Now, see, what you have here are two equations and two unknowns. The unknowns are t and the initial velocity, v sub 0. So, I have already solved for t in the first equation, and I'm going to now substitute that in for the second equation, and I will let you do the algebra. That I have v0 sine of 35, and t is 130 over v sub 0 cosine 35 minus 4.9, and then I have to square t. That would be 130 squared over v sub 0 squared cosine 35 squared. Okay, the only thing I'll tell you right now, and this will become very useful many times, is sine of 35 over cosine of 35 happens to be tangent of 35. But basically what happens here is these v naughts cancel, and what I can do is figure out what this number is and then move it to the other side, and then it's rather easy to solve. But our final answer here for initial velocity, according to my calculations, happens to be 41.7 meters per second. Okay, now if that is my initial velocity, then I can use any of the four parametric equations. In the parametric equations, you can find distances, velocities at any point on the parabola. So I would suggest using this first equation to find the time that it hits the wall, and then once you find the time, you can find the velocities at that point on the wall.